Yeah, no tsunamis or volcanoes in Pennsylvania, I guess, right? I'm going to give just a couple minutes overview of the project, and then my colleague, you will talk about the design aspect of the project. There's really a two-part process to this. We ended up designing a series of maps for emergency responders. I'll get into the details of that here in just a minute. But it spanned over 2 football seasons. So we'll have part 1 and part 2. So this is Beaver Stadium. It's a colossal stadium, football stadium in Penn State. I forget how many, it's like 80,000, 90,000 people, right? A lot of folks. But when you stand in the stadium or outside the stadium, people normally talk about north, south, east, west of the stadium. That's fine, but the problem is the stadium isn't aligned north, south, east, and west. So the problem is that when people say, I'm west of the stadium, it's not really true. Coupled with the fact that, as I found out, with most Big Ten stadiums or football stadiums of this size, there are snipers on top of the stadiums that, I guess when things go bad, they call in for help or take out the bad guy. I don't know. They came to me one day and said, hey, I hear you know something about map projections. Yeah, okay. So they said, we have this problem that we need to have solved. We need a grid system that is aligned to Beaver Stadium so that when something happens, we can refer to a location, not using GPS, but a simple grid code. No problem. Got you covered. Okay. So I delved a little bit back into history. The German Navy during World War II created a grid system that covered the world's ocean. And the grid system was very simple. You can kind of think township and range in the sense it's a hierarchical system. It starts with a large nautical square mile down to a very small nautical square mile. And the reason they did a grid system is that the communication between the U-boats, for example, and the home station required, in some cases, 47 characters compared to only 20 for a grid designation. And there's all kinds of reasons why they'd want to minimize the number of radio signals, for example, being tracked and targeted by destroyers, for example. So the basic system operates on a 486 by 486 nautical mile grid square. You can see the red dot is the location. As you kind of drill down into that system, you can get a relatively crisp resolution of 6 by 6 nautical miles. So in that square, you can find a vessel or a U-boat with pretty good accuracy. So snipers, so the SWAT team came to visit me. They were all in their garb, kind of intimidating, but yes sir, no sir. But they told me they preferred yards, which, whatever units, that's fine. They wanted a grid system, as I said, that was simple. So I proposed this idea of having a double letter, a double number, and then you would drill down A, B, C, D, 1, 2, 3, 4. Most of those fellows are ex-military. They're used to working with the military grid reference system. Instant hit, right? I said, great, we'll work something up for you. And with that, I'll turn things over to you.
Hello everyone. My name is Yu. You can call me Sabrina if you find it hard to pronounce my Chinese name. I'm now going to be talking about the details of the 2-part project. So initially, these are the constraints and expectations of the initial project. So they want us to have 4 small map booklets, 1 for each of the patron zone, and also 1 big map for the command central. And also inside each of the booklet, we should have an easy identification of location name and grid code so that it's quickly. It's an emergency use, so it should be very easy. They want us to finish, of course, by the end of the first home football game of 2018 season. And these are the 3 layers of our data. However, in order to cooperate all of them into 1 booklet is a bit of a problem because we want to contrast the roads with the parking spaces. And also we want to contrast the grid with the orthophoto and as you can tell, it's a very rich color photo. You don't want them to stand out too much. And also each of the lot have a color to it. You want to color code those lot numbers. And this is the final grid for the initial design. So we added the transparent field to distinguish the parking lot colors. And also we diminished the saturation of the orthophoto to make it not stand out. Also, we make the grid line colors visible against both dark, light, different color background, and with vary weights. And this is what it looks like. Luckily, I bring this here today, and this is what it looks like. It's a very small booklet. You have like the labels, horizontal and vertical labels, and that's how you read it. And at the bottom, you say a mark like which parking lots is included in this page. Feel free to look at this after my speech. Okay. Initially, the positive feedback is they're pretty good, and they say like they're able to locate and help heart attack victim. And also the responders, they were better able to explain their location with the booklet. However, the design is not always perfect. So because of such a small booklet, sometimes the smallest grid size, like the 12.5 yards, they're not really practical for the map. Also, we have the lot color designation, and they want us to eliminate it and create one booklet containing all the maps. So that's why we have the part 2 of the project. It's for this year, for the revision. And still it's the one small booklet, but for this time they want us to put everything in one book and also have one big map for the Command Central. Since we don't have the color coding and the small grid lines, so we need to do more revisions to the data. And this is what the revision data look like. These are the data from the police department. So each of the lot has a number to it without color, so it's very hard. So this is like the revision grid design looks like, and as you can tell, it's so much easier to read it. Like the red square in the central, you read as AA10. So it's so much easier than the previous ones. And a bit of the challenges, because now we have no area fields and no small grid lines, no color parking lot coding. So we have to revise the previous map page a little bit. And this is the process for it. And we first try with the black grid and boundary line combo color. However, it is very confusing. You cannot tell like the difference between the boundaries and the grids. And then we try with like the blue grid and the black boundary line combo, because we pick blue because it's apparently a Penn State color. Yes, yeah, that's true. And and as you can tell, but it's still, the black color is not very outstanding. It's still a bit of hard to tell. And finally, we decided to use the pink grid. Oh, there's the typo. Use the pink grid and blue boundary line combo. By the way, pink is the original Penn State color. Yes. And this time, the grid is so much more stand out. And this is like what the revised grid design look like. And because the grid is so much easier to read, so we decided not to insert like the small instruction of how to read it for every page. Like this is the last initial version. So on every page you have the small squares showing like how to read it. But this time it's so much easier, so we just get rid of that. And some of the feedbacks on the revised grid design, overall, like the responders, they like all the maps in one book, and they love the fact that we removed the inner grid, so it's so much easier for them to read. However, they could wish us to improve by labeling all those different buildings, so they could just take a look at faster. Some of the next steps, it would be great if we can just apply this grid to the entire Central County CAD systems. And also, we can develop a mobile application for all the users to use it. And then we also can apply the grids to the entire campus. And thank you for your attention. That's it. Any questions?